calculating the extent of validation of the conclusions. Diagnosing depth recognition module. Main task of the diagnose depth recognition module is to identify the distribution of the disease symptoms. The task on these facts, diagnose module decides the depth of the diagnosing process. If the distribution of the symptoms is too high, then the diagnose process must be done more deeply. During a deep diagnosing process, some more diseases have to be considered. If the distribution of the disease symptoms is low, depth of the diagnosing process is also low. Question generation module. This is kind of an intermediary between the decision making process and the diagnosing process. If the diagnose module wants to know some additional information, like if he want to clarify something from the user, the diagnose module requests this information from the question generation module. When the question generation module receives this information, it asks appropriate questions from the user. In this case, it will use the user interface to prompt the user. And also, the answers provided by the user is passed out to the diagnose module to continue the diagnosing process. The treatment module. So, the system is capable of providing the treatment according to its diagnosis. So here, the treatment module facilitates the generation of suitable treatments for the final outcoming diseases. In this case, it will provide suitable treatments for the patient or the user. The next important thing is the explanation handling module. The main task of the explanation handling module is getting information about the diagnosing process from the diagnosing module and generating the explanations about the final diagnosis. The one that we have to keep in mind is the system is able to provide the explanations for its conclusions. So this is a feature of the traditional expert system. As a human doctor, this expert system is also capable of providing the reasons for its conclusions. The next thing is the clinical test module. So the clinical test module has an ability to conclude the suitable clinical test. In this case, the system can use the reports from the clinical test which has done against the patient. Okay, now let's see how the system is working. So here we are using the basic design of the system, kind of an illustration, to show you that how the system is going to diagnose a particular patient. So first, here you can see the user interface of the system. A small database is used to keep the static data, and then the inference engine. So finally, the knowledge base. Here you can see the knowledge base consists with 6 different modules: the diagnosing module, diagnosing depth recognition module, question generation module, treatment module, clinical test module, and the explanation generation module. So once the user inputs its symptoms, his or her symptoms, to the system, what the system will do, the inference engine will pass those symptoms into the knowledge base. First, the diagnose module will take these symptoms, and using the diagnosing depth recognition module, it will decide that the place where the symptoms are applied. In this case, what I mean by the places, the human respiratory system is considered as or divided into 3 parts. First thing is the upper respiratory and the middle respiratory and the lower respiratory. So the diagnosis is done based on these three parts. So the diagnose depth recognition module is doing or deciding where the disease has occurred, whether it is in the middle, lower or the upper. Then if the diagnose module doesn't have the enough information to come up with some kind of a conclusion, it will focus on to the question generation module. Then it will generate some questions depending on the inputs or the information entered by the user as the user inputs. Then it will generate some unique questions depending on the user inputs. So the user has to answer these questions. Once the user has answered these questions, the user interface will again pass this into the question generation module and it will return it into the diagnosing module. So by using these further clarifications, the diagnosing module will come up with the conclusion or the possible diseases the patient could have. Then it will join with the treatment module to decide what are the suitable solutions or the treatment to the patient, and it will list out the possible treatment the patient should get. So here we have illustrated the clinical test module of the knowledge base. What it does is, so the diagnose module can use several reports of the clinical test module to come up with its conclusion or to have the support of these clinical tests. Then another important part, the explanation generation module. What it does is, so once the diagnose module has come up with its conclusion or the possible diseases the patient should have, so this explanation module will be able to explain the conclusion by giving the rules it has applied. So here it is able to explain their conclusion. Another important thing, the user can ask questions or the patient can ask questions from the system. Let's say the system gives its conclusion as the patient is having pneumonia. So the patient can ask from the system, it cannot be laryngitis or maybe bronchitis. So again it will restart the diagnosing process from somewhere in the middle. Again maybe it will ask some questions and to clarify the diagnosis. So then it will give the possible answer, it can be or maybe not. So here likewise, this is how basically this expert system, which is implemented using the Prolog and the Flex expert system shell, is used. You can see it is act as a human doctor. So the patient or the user can input the symptoms he or her having, and then the system will give the possible diseases for the patient. So this is kind of a process where the human doctor does. 3. Okay, now let's see the how expert system works.
Entering inputs to the system. The use of the system can be a doctor, a patient or any other person. When a user needs to get services from the system
Of calculating